Okay, so some of these questions you guys had for homework or just a good old tutorial if you're watching this on YouTube. We have a question where a field hockey player starts from rest, accelerates uniformly to a speed of 4 meters per second, and she does that in 2.5 seconds. So the question wants you to determine the distance that she traveled. So I'm going to write down some of the information that's given. Start from rest. That tells us that our initial speed, VI, is 0. You accelerate uniformly to a speed of 4 meters per second, so VF, final speed, 4.0 meters per second, and this is done in a time of 2.5 seconds. So when the question wants to know the distance traveled, you got to try and figure out what type of formula you'd want to use. So there's two distance formulas you could use, VI plus VF over 2, using it like an average speed times time. And the other distance formula you could possibly use is VIT plus 1/2 AT squared. The problem is you do not have the acceleration yet for the question. Okay, so you could try and find the acceleration using a separate formula and then do this question. If it was me, I would do part B first. But we could just proceed in a fairly linear fashion and solve using the distance as VI plus VF over 2 times the time. So that would leave us that the distance is 0 plus 4 over 2, then times 2.5. So that gives us a pretty clear answer of 5 meters when you work that one out. So the distance traveled is 5 meters. Now part B wants to know what's the acceleration. So there's a few options you have. Acceleration you could use as a formula VF minus VI over T to figure out the acceleration. So the acceleration would be 4 meters per second minus 0 meters per second, divide by 2.5 seconds. And just in case you thought you could grab your calculator and work that one out, there's really no need, because if you have 4 over 2.5, I'd multiply top and bottom by 4. That would give me 16 over 10, which is clearly 1.6. All right, don't use a calculator if you don't need to. So 1.6 meters per second squared is the acceleration. So that gives us answers to both the distance traveled and the acceleration. So if I slip down to question 5, this is one where you're going to have to look at my second video I have, because in this question you've got Michael running and Robert running at a different speed. So Mike's running at 8.8 meters per second, but he's going to accelerate and try and catch up. And this question wants to know how far are you going to have to go to catch up to him, and how long is it going to take? To do that question is going to require some trickier math, and that's why I made a whole separate video on that. So the video later on in class that you're going to watch, or you have to look it up online, you'll find the other video that helps you solve this problem. So I'm going to move along to the next one, because number 5, it's kind of, we'll look at it later. So in number 6, a race car accelerates at 5 meters per second squared. So I'll write A equals, well, not 6, I'll try 5 meters per second squared. If the initial velocity is 200 kilometers per hour, how far has it traveled, distance equals question mark, after time of 8 seconds? Okay, so barrier to the question is units. These units here, meters per second squared, other units are in kilometers per hour. To convert from kilometers per hour to meters per second, we'll divide by 3.6. So we got to bring up the calculator, and it's not on. It's supposed to be on. There we go. So we're going to take 200 and divide by 3.6, and that'll give us 55.5 repeating kilometers per hour, or meters per second. Okay, so I'll get rid of the calculator for a bit. There's a decimal in there. So now we can proceed and solve the question. How far has it traveled after 8 seconds? The formula for distance says VIT plus 1/2 AT squared. So 55 and a bunch of 5s is the VI. Time is 8 seconds plus 1/2 acceleration was 5, and 8 squared. Okay, so we'll bring that calculator back up. Hopefully it stayed on this time. Okay, so that answer, so we'll put the answer in there, times 8 plus 0.5 times 5 times 64, which is 8 squared. Gives me an answer of 604.4 meters. A little quick look at how many significant digits that should be. My question up here, they've gone to great pains to make it 2 significant digits. So we have to round that off to 2 significant digits. So if you rounded it to 604, you'd have 3 significant digits. If you rounded it to 600, you'd have 1 significant digit. Oh my, what do we do to solve this problem? We could write it in scientific notation, and that way you would have 2 significant digits, 6.0 times 10 to the 2. Quite a little trick for that one. Alrighty, we're getting there. Number 7. A motorist is traveling at 20 meters per second. So that sounds like the first speed, initial speed of 20 meters per second, when she observes a traffic light that's 150 meters ahead. So 150 meters ahead, we'll draw a fancy car, traffic light, 150 meters up the road. The traffic light is going to stay red for a time of 10 seconds. If the motorist wants to pass without stopping just as it turns green, which is a highly unsafe practice, but we'll carry on. They want to slide through just when it turns green. What would the speed of the car be, VF equals question mark, just as it passes the light? So we have distances, times, and we want to know the final speed. You can solve this by first finding the acceleration, use VI, D, and time. You could solve for A, then use that acceleration to solve for VF. However, that formula that's kind of greasy, that I'm not a big fan of VI plus VF over 2 times time, will get us to our answer much quicker, because we are now trying to solve for VF. So I'll rearrange the formula before I put numbers in, because that's just how we roll around here. So we're going to put 2D equals VI plus VF times T. We took the 2 up. Then we're going to divide both sides by T, and that makes this go away. And then I'm going to take the VI over and subtract. So 2 times the distance over time minus VI will give me the final speed. So 2 times the distance of 150 meters, divide by the time of 10, subtract my initial speed, which escapes me, 20 meters per second, will give us VF. Of course, we're not bringing the calculator up for this. 2 times 150 is 300. 300 divided by 10 is 30. Minus 20, shouldn't be a big stretch for us, 10 meters per second will be the speed that the motorist is doing as they hurtle into an intersection, hoping that some person coming the other way isn't running a yellow and causing a catastrophic accident. Alright, so I've left a question out. That's going to be another video for you. This should be good enough for now.